Hi students, in this video we'll discuss FSMs to operational systems, simulators for FSM and bidirectional transducer. The first is FSM to operational system. You know what is FSM? Finite state machine, or I can say as finite automata. The first application is designing digital circuits. The next is compiler construction. When I write a program, in any language, let it be C, C++, Java or Python, all these are high level languages. But computer can understand only machine level language, and this high level language has to be converted into machine level language that is done by compiler. You people, you know this, right? So one of the main application of my FSM is compiler construction. In compiler, we are having 7 phases, right? In that, I'll be using this finite automata. The major application of finite automata is compiler construction. Next is string matching, then string processing, right? String matching, string processing is and all, right? Recognizing the voice, we can have the text message. For that purpose also, I can use this finite state machines. And then software design. These are few applications of my finite state machines. Next is simulators for FSM. Right, we have learned how to design an FSM. We have studied the applications of FSM. Now we can see how I can simulate an FSM. Right. So here a question is given like state A taking A in Q naught state, taking A input and staying in Q naught state. When it takes B input, it is moving to Q1, and Q1 state, when it takes A input, it is staying in Q1. Right, now for this I have to write a simulator. Right, I'll write this state 0. If the scanned character is A, if the scanned character is A, it goes to state Q0. If the scanned character is B, it goes to Q1. If end of string, then accept the string. Right, what is the meaning of this DFA or DFSM? Right, it should accept there should be exactly one B, right? There should be exactly one B. I can have any number of A's, but it should have exactly one B, right? And coming to this Q1 state, when the scan character is A, it goes to Q1. If the scan character is B, then reject the string, right? If Q1 state accepts any B symbol, I should reject it. I told, seeing this DFA, I can understand this DFA, right? It is designed to accept exactly one B. So if Q1 accepts one more B, my string becomes invalid and I should reject it. That's what happening here. Then reject the string. If end of the string, then accept the string. For this, I have to write a simulator. Right, CS, I start with my start state Q0, right? Get next simple until you reach your end of character, and every time you have to calculate the transition for that symbol, input symbol, right? Until you reach your end of character, you should repeat this process. If the current state is your final state, then accept it, else reject it. Once you process the complete string, at the end of the string, if you are in your final state, then you can accept it or you have to reject it. This is how I can write a simulator for my FSM. For every FSM I have designed, I can write a simulator. Then coming to the third topic, it is bidirectional transducer. We have studied transducer very clearly in the previous videos, and we have learned an example. We know what is transducer. Transducer is nothing but finite state machines with output is known as finite state transducers. Right now, all the finite state machines are language recognizer. Right, if I need an output, I should go for finite state transducer. Under finite state transducer, in the previous video, we have learned Mealy emission and Moore emission, right? So whatever example we have learned in the previous video, it is just unidirectional transducer. Right now in this video, we can learn bidirectional transducer. This bidirectional transducer, it works in both the ways. It is two-way. It can work forward and it can work in the reverse direction. Right, and one best example for this bidirectional transducer is my Soundex algorithm. Right, Soundex algorithm. First, I'll explain this algorithm. The purpose of this algorithm is like some people they may change their name, right? They may change the spelling of their name, or they may change the name if they migrate to a country with different language, with different writing systems, with different sounding systems, right? So when they move to a different place, they may change their name. Now, if I want to find the people related to these people, right? What I can do is like, suppose if there is a change in the name, it is very difficult to identify the related people. So I can use this Soundex algorithm. As I said, this Soundex algorithm, it is an example for bidirectional transducer. It is an example for bidirectional transducer. That is, it works in both the ways. So keep getting that name. When it works forward, that is name to code. That is the uh, first step, right? So for every name, it will generate a code. This code is the first letter. The first symbol of this code will be an uppercase alphabet. Remaining 4 digits, numerals it will have, right? So when I run this algorithm by feeding the name, I'll get a code, 4-digit code, right? Now the next step is I have to give the code, right? I'm working in reverse direction. I'll give the code whatever I have generated. So when I execute this code, corresponding names, right? Corresponding names I'll get it. So that with this I can find out the people related to this people, right? So this is what the algorithm is. Keep the first letter of the name, right? How, see, it is a 4-digit code. First digit will be your uppercase alphabet. Rest 3 I'll get a numeral. Totally it will be a 4-digit code, right? So any name you can take it, right? So for all these names, how will I get a code? First uh, alphabet in uppercase, remaining 3 digits I can have. So in Soundex algorithm, so what I'll do, first I'll feed a name, I'll get a code, and in the next step I have to feed the code, you'll get the list of names. The list of names related to this name, so that with those names I can identify the people even if they change their spelling a little bit, right? So this is the algorithm, how I am getting the code. This is the, say for BFPB, I'll use the number 1. For these alphabets, I'll use the digit 2. For D and T, I'll use the digit 3. Likewise, this is my algorithm part, right? This is how I am generating a 4-digit code. So Soundex algorithm is the best example for my bidirectional transducer. Thank you.